Western Michigan University Chainless Challenge team. We also have Lewis here, Dex, Austin, Andrew, and Cameron. Myself, Austin, Andrew, and Cameron were focused on the mechanical aspect of the bike, and Dex and Lewis were focused on the electrical system that we have for the bike itself.
Do you want to walk us through the bike's design real quick?
Definitely. So the first thing that we start off with the bike itself, the frame is a custom frame here. We use the same one from the 2012 bike. Due to the modifications that we made for our design here, we had to cut that frame and weld an extension on here, so you notice that the bike frame is actually about 6 inches or so longer to accommodate all the components that we have on there. The next major challenge that we have for our bike itself was the implementation of this gear hub right here. So what we did, we have multiple gears in here that are running from the pedal into this pump here to maximize the efficiency of the pumps to get the highest RPM during operation. That was one of the major innovations that we've incorporated into this bike from previous years, is the actual implementation of this hub with a variety of gear ratios to be able to change the RPM of our pump. Coming back here, most notably, we've tried to keep all of our valves and all of our lines and fittings within the same area, just to minimize the overall length of lines that we'd have, to minimize the loss that we have in the system, therefore making it more efficient over the long run. The main component you see back here is the electrical system. We have the main microcontroller here, which is basically the brains of the operation, containing algorithms that actually control the valves back here to direct the flow into the accumulators and also into our direct drive operation as well. We also feature a display screen up here as part of the electrical system that displays the speed that we are operating at, as well as various pressure readings within the system itself. Just kind of the overall bike here, we've tried to focus on standardizing all of our fittings and fixtures. So these bolts here, as far as our mounts go, are all the same. We try to keep them, the same. So whenever if we need to perform maintenance on the bike itself, we could do that easily without the use of many tools. So that was one thing we definitely focused on. We also tried to keep everything as light as possible, so a lot of the mounting components and brackets are made of aluminum, just to keep the weight down and still be able to function correctly as well. Overall, we kept the bike weight pretty low. It's around 170 pounds or so, an improvement from past year's design, so we definitely feel like that's a positive for our team.
As a whole, what was your exposure to fluid power, pneumatics, hydraulics before this project?
So myself, I've had very limited exposure to fluid mechanics. Austin, Cameron, and Andrew have had a little bit more experience with the hydraulics, so a lot of theoretical knowledge. This whole experience of actually putting it together in a physical application is new to all of us. So that's definitely something that we all learned from this project, is actually taking what we've learned theoretically with equations and calculations and actually applying it to a physical project such as this. So that's one thing that we've definitely incorporated our experience in various fields to come together to complete this project.
So it enriched your engineering experience, would you say?
Absolutely. This was probably one of the hardest things that we've done in our college experience. I think I could probably speak for everyone about that. Definitely one of the most rewarding, though. I think one of the best, applications for this project is to take what we learned here and apply it when we work out in industry, when we graduate. Taking a problem that we have and coming up with various ideas to solve that problem, selecting which one best fits that and best suits our needs, and then testing it and making modifications to that system, and overall producing a product that we completed on time and was able to complete all of the challenges that we set out to accomplish.
Any advice for those that come after you, future teams?
Work well together. Go with your gut. Don't always, the advisors might not like this. Advisors aren't always necessarily right. And maybe you guys might have a better idea than they had, and plan a lot, plan testing time. That's very important.
Okay.
I definitely just echo what they said too. Just plan a set time where you can actually test all of the systems on the bike itself, just to make sure that everything functions correctly, and just make sure that you have set aside time for each part of the operation and not leave anything, just to get it done when we can, but actually allocating specific time to accomplish something. I would say just managing your time and making sure you prioritize is probably one of the biggest challenges that we've had for this project.
And you said teamwork?
Absolutely.
Yeah.
We all four of us worked really well together. Had no problems with each other. Great communication, and that's how you get stuff done.
Yep. Sometimes, you can't, this is the best way to put it. Just because you think you're always right and you have the best idea, it was definitely a good learning experience to step aside and let each person work their own thing out, kind of divide and conquer.
Mm-hmm.